Well, we are going to start slowly getting into graphing. And before we do that, we need to understand what relations are and what ordered pairs are. So I found this cute picture of a dog and a cat and some chicken and some milk. So we're going to just use this to show two different sets. We've got set A and set B. And when I put them together, they're going to equal set AB, where I'm just going to match them up, like the dog and the chicken would be our first relation here. The dog and the cat and the milk go together. I can put the dog and the milk together, and I can put the cat and the chicken together. So this is all the ways that these two sets can be combined. And this right here is our set of ordered pairs. It's just an ordered pair, the dog and the chicken. I just think that's so cute. Anyway, this is the fancy way to say this is called a Cartesian product. And the Cartesian product of two sets, A and B, symbolize A times B, is the set of all ordered pairs having the first member from set A and the second member from set B. So it's really not times, it's just put with it. This set associated with the set. And that's just the way it's written. So down here I've got a bigger type examples. Not as cute as the cat and the dog, but just thought I'd start it off with that. You may be asked to find the Cartesian product of Q and Q. Well, Q is the same thing. It's just two of them with the numbers 2, 3, 4, and 5. So if we have two of those together, what are all of the ordered pairs that we can find using these numbers? Well, if there's two sets that look just like this, I would have a 2 and a 2 with a 3, a 2 with a 4, and a 2 with a 5. And then if I moved to my 3, I would have a 3 with a 2, a 3 with a 3, a 3 with a 4, a 3 with a 5. And remember, there's two of these because we're doing two of them together. I just didn't write it twice. We don't need to because it's the same thing. Then I move to the 4. I'd have the 4 with the 2, the 4 with the 3, the 4 with the 4, and the 4 with the 5. And lastly, the 5. The 5 with the 2, the 5 with the 3, the 5 with the 4, and the 5 with the other 5. So this right here is the Cartesian product, and it's just the set of all the ordered pairs from what you're given, set A first and set B second. Now, here's just a smaller example down here is find the Cartesian product of A with B, and where A is equal to DE and B is equal to 1, 2. So if I put those together, I can put D with 1 right here, D with 2, just like this, E with 1, and E with 2. So this would be our Cartesian product. Now you may be asked to list ordered pairs from a Cartesian product that satisfy like a given relation. And you can hear my dogs maybe barking in the background. They're getting excited. So anyway, try to ignore them if you can hear them. In the following Cartesian product, list the set of ordered pairs for which the first member is less than the second member. So I have this list right here, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. And we're looking for the list where the first member is less than the second member. So out of all of these, only 3 of them qualify. 1 is less than 2, and 1 is less than 3, and 2 is less than 3. So I was able to include all of those in my final set here. Now, lastly, I'm going to show you that these ordered pairs actually have names for each of the numbers in them. They're called a domain and range. Alright, so Any set of ordered pairs selected from a Cartesian product is a relation. There's like a relation between one number and the first number and the second number. A relation from a set A to a set B is any set of ordered pairs A and B. So the set of all first members in a relation is the domain of the relation. So the first members up here, if I scroll up, are 1, there's another 1, and a 2. So my domain is 1 and 2. The set of all second members in a relation is the range of the relation. So if I look back up here again, the second members are 2 and 3. So if you scroll down, the range is 2 and 3. Now, knowing that, we can solve or answer a couple other questions. List the domain and range of this relation. A1, B2, C3, and E2. Look at that. I made a mistake. That's supposed to say 4. I love it when I find mistakes when I'm recording something. So I'm just going to cross that out. You can pretend that that's really a 4. Ha. There we go. There. That's about the neatest I can write it. So my domain is all of my first members, A, B, C, and D. Look at that. I wrote E and I wrote D over here. I am so sorry. Just hopefully y'all can just get a laugh out of that. That is supposed to be a D. Good grief. Oh, there we go. D. A, B, C, and D. Ha. Just seeing if y'all caught that. The range is 1, 2, 3, and 4. Magically. So there's my range. The second set of numbers. Second members in that relation. Now, greater than, less than, it's not leaving us. It's still here. Use this set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, to find x such that 2 is less than x is less than 8. So I need to find all the numbers in this set that would match this. That means x has to be bigger than 2 and less than 8. And out of the set that I'm given, the ones that match that are bigger than 2 and less than 8 are 3, 4, 5, 6, and 7. Ha! Didn't make a mistake in that one. Yay! Hopefully I won't have one in this one either. This is my last one. Now, it says to use the relation Q with another Q where Q equals 2, 3, 4, and 5. So remember there's actually 2 of those. And I did not write down all of the ordered pairs that would come out of this. It's just too many. But I am looking for ordered pairs, x, y, where y is bigger than whatever the x is plus 1. Now, x is our first, so it's our domain, and y is our range. And if you listed all of these out, all of the ordered pairs that you would have, like 2, 2, 2, 3, 2, 4, 2, 5, then 3, 2, 3, 3, 3, 4, 3, 5, and so forth and so on. The ones that would match this were the second part, y, the range, has to be bigger than the domain x plus 1. The only ones that match that are 2, 5, 2, 4, and 3, 5. Now, I didn't do all the heavy work over here, but you may be asked to do that and find a special relation within all of these ordered pairs. So that is our first lesson on ordered pairs and relations, and we will go into graphing very, very soon. Thank you.